right, so we're going to start our last section in chapter 2, and we're going to spend a couple days on this because it's all about derivatives, which are one of the two huge fundamental pieces of calculus. So we're going to start by defining what a derivative is and talk about their graphs. So make sure you got yourself all ready for notes, and we're going to get started. Now, a derivative, it's written as for example, we see here, f is the function, and then the derivative of f is written as f prime. That's what we call it when it's got a little apostrophe like this. And what it is a graph or a function that plots the slope. So we've been talking a lot about slopes of tangents and graphs, and the derivative is a function that plots the slope of another function. In this case, if this is f prime, it has the slope of f. Now, we've seen this idea before. So the idea is that f prime of a is equal to the slope of f of x at x equals a. So f prime is equal to this limit formula that we have here of the slope of a function. And we'll be using this to do some actual mathematical calculations, but we're going to just start with using the graphs, drawing in some estimations on tangent lines. Now, I understand that this is like an odd new concept, so I think it's easier to look at a couple of examples, and then of course, please do set up Zoom meetings if you have questions, nominate questions in the form, and leave me comments where you're confused. So, using the graph of f of x, estimate the derivatives. So this says f prime of -2. So as a reminder, that means what is the slope of f of x at -2? That's all that's asking. So we look at -2 here. We can sketch in a basic tangent line. It's pretty steep. And we can estimate the slope. And in this case, I would estimate the slope as over 1, maybe up 5. So I'm going to say this is a positive 5 slope, which means f prime of -2 would be 5. Now it's asking for a couple more points. It's saying f inverse at -1. Well, here's f of -1. Not f inverse, I apologize, f prime, the derivative. And I would say that slope, it's definitely negative, right, because it's going down. And it's going to be about -1. Now, because we're using a graph, we're doing it as best we can. These are going to be estimations, but we'll try our best. At f of 0, we can see that we're still looking at a negative slope, right like that. So I would estimate this slope as -3, though of course if you had -2, -2.5, those are reasonable. Our next slope will be at +1. So f prime of 1, still negative, but less. So I'm going to say that one also has a slope of -1. And then finally, f prime at 2. So now our tangent line is positive again. And I'm going to say, estimating that that's going over 1, up 5. So again, these are all estimations. We're looking at the tangent lines and estimating the slopes, and that gives us our derivatives. So this part should feel very familiar. Now, f prime of x is itself a graph, is a function that you can write out, and that's what we're going to do in number 2. Oh, one other important thing to note that I wanted to remind myself and you of is that at the minimum and maximum, so if I look at the graph here, we have a lovely minimum. At this point, right after 1, the slope is going to be 0. So at a minimum or maximum, the tangent is horizontal, which means that the slope is equal to 0, which also means that f prime is equal to 0 at that point. So just something helpful to note. So based on your answers in number 1, we're going to sketch the derivative. So what you're going to do is take all those answers that we had here, and we're going to turn them into ordered pairs. So we had -1, -1, -2, 5, 0, -3, 1, -1, 2, 5. So we have our nice ordered pairs. Oh, I guess I said 2, 3 in the last answer. Let's see. Yeah, I'd say that's a better approximation. Sorry about that. Doing my corrections. And now we're going to plot them on here. And we'll plot them the same way we would if these were a traditional function. We'll take our ordered pairs. -2, 5 would be a point there. -1, -1, 0, -3, 1, -1, and 2, +3. All right. So here we have our pairs, and it's just a sketch, so I'm going to come down here, go through the points that I can, and we see that we have a rough parabola, which, very rough, I apologize. But this will actually make sense, and this is a pattern that's going to hold with derivatives that we'll see in our next lesson, is if this kind of looks like a cubic one or a degree 3 graph, the derivative is going to look like a degree 2 graph. If you have something that's a degree 7, the derivative is going to look like a degree 6. So derivatives have one lower degree than the original, which is just going to be a nice way to check your work. So it's like, oh, this kind of looked like a cubic like that. Then this one is going to look like a parabola. I know this is new. We're going to go through this nice and slow so that I know all of you feel confident before we move on. If you do have questions, and I strongly encourage you to set up that Zoom meeting, put questions in the comments, nominate homework questions, all of those. I'll talk to you later.